Welcome to clickmyproject.com. The title of this paper is Feature Subset Selection Wrapper Based on Mutual Information and Rough Sets. In this, we are going to see about the concept of feature selection. What is feature selection? Selecting the most effective attributes from a given data set is called feature selection. This is mainly used in most of the application where high dimensional data is to be processed. In such applications, feature selection plays a key role because for example in classification problems, while classifying a disease or something, we need to predict some feature selection algorithms. That is, we will be finding which attribute is effective, and based on that attribute we will be proceeding with the classification problems. For finding such approaches, we will use the feature selection algorithm. Irrelevant and redundant features in input features do not complicate the problem but also degrade solution accuracy, because ineffective features may lead to some inaccuracy in the proposed work. Our aim is to select the essential features that allow us to improve the accuracy belonging to different classes. The most popular method for feature selection problem is principal component analysis. This transforms the existing features into the new ones, that is, it will form the effective feature subset. This method is not suitable for classification problem because it needs to process all the data when new data is added. The other disadvantage of PCA is that it is not invariant under a transformation of the data. So we will propose a new method based on wrapper based and mutual information rough sets, and we will be producing an effective feature set. In all feature selection methods, we can divide the feature selection methods into two categories. In that two categories, the first one is the filter method and the second one is the wrapper method. Filter method selects a subset of features as a pre-processing step which is independent from the induction algorithm. The best feature subset is selected by evaluating some predefined criterion without involving any learning algorithms. Therefore, this concept usually considers a faster speed importantly. Moreover, the filter method is computationally less expensive and more general, but wrapper methods utilize the performance of the classifier algorithms to evaluate the worth of feature subsets. The wrapper method can yield high classification accuracy for a particular classifier. It also computational complexity is high and less generalization of the selected features on other classifiers. The wrapper method generally outperforms the filter method in the aspect of accuracy of the learning machine. Hence, our proposed work uses that wrapper-based methods and combines it with mutual information and rough sets to form a hybrid model. Hence, this paper proposes an approach that effectively selects relevant features based on mutual information for ranking. A candidate feature set is selected from the top of ranking list by selecting the subset of features with highest classification accuracy. To decrease the computational cost of wrapper search to searches for the proper subset of feature through a candidate feature set, we do approximate super reduction on candidate feature set by using a technique named VPRSM. This super reduct has redundant or relevant features is combined with wrapper schemes to find a proper reduct which improves the classification accuracy. Finally, we find a proper reduct in which ordered features of super reduct are removed using a wrapper subset evaluation. This approach provides the possibility of efficiently applying filter wrapper model on some datasets from the UCI repository. Now I will explain the system architecture of this. Initially, we have to load the data, that is, it may be any high dimensional data. For example, it may be a cancer dataset or any medical dataset. Then we have to pre-process it. Pre-processing in the sense we will be removing the missing values, or we will be performing some operations to remove the noise and outliers. After that, we will be performing MI based feature attribute separation. Attribute separation in the sense it will be selecting initial set of features using the MI concept, and from that we will be separating it into continuous attributes and decision attributes. For that attributes we will be calculating the maximum quality accuracy, that is which attribute has the maximum classification accuracy. We will be finding using the mathematical analysis, and from that we will form the super reduced set. Likewise, we will be forming iterative super reduced sets for the set of features, and we will be merging it with the those attributes with and to form a effective attribute set. Iterative super reduced in the sense will be providing training set and a testing set. There is a set of features obtained from the training set, and also from the testing set is merged here, and finally we will be reducing the filter we will be reducing the attribute set by applying the filter model, and we will be displaying the result here. This is the flow of our project. Now I will show the demo of this project. For that we need NetBeans and WAMP server. WAMP server access the database. In that select home and right click on that and select run file. We have to choose the data set, that is a training set or something. Here I am choosing br.csv, and it is converted into an ARF format. After converting, we have to extract the data and we have to store it in the database. It is shown here. Initially will be this much features is in the data set. For that we will be applying the mutual information selection method, and we will be separating the attributes into decision attributes and conditional attributes. After that we will be performing classification accuracy. For finding the classification accuracy, we have to perform these mathematical calculations, and we will be providing the accuracy for each attribute. Here it is shown. Then we will be calculating some mathematical analysis, and we will be finding which attributes that have the greater value than the Cmax will be selected as the final attribute set, and for that we will be calculating set A and super reduced set, and the super reduced set is shown here. Likewise, we will be performing the same thing for another one thing, that is a test set. We will be giving bbb.csv, and for that also converted to be an ARF format, and extract data, show data and initial features. The same process is repeated again, and for that also we will be calculating the classification accuracy, and the accuracy of those values are shown here, and we will be calculating the E value, Cmax value, and the attributes with the values greater than Cmax is shown here, and we will be finding the super reduced set of this, and we will be combining the super reduced 1 and super reduced 2. This is iterative super reduced, and we will be removing the redundant attributes from this. We will be combining both super reduced, and we will be removing the redundant attributes, and we will be performing finding accuracy of this attributes for a feature subset 1, and this is for subset 2. The accuracy is shown here. Thus our project ends with this. Thanks for listening the video. Thank you.